Hi, Chance. Thank you for joining in. We'll be getting started here shortly, maybe about 5 to 6 minutes. Appreciate your patience. We'll get started in about 5 minutes or so. Thanks for your patience. Let's wait 1 minute more or so for folk who might be figuring out how to get to us, and then we'll get started. Thanks for your patience.
Testing microphone. Test, 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 test. Test microphone. Test, test.
Microphone is working perfectly fine, Alan. Thank you.
Oh, sorry, ma'am. I was testing on the Zoom thing. I didn't know it was transmitting to the.
Yeah. Not a problem at all. That'll come in handy if you have a question.
Test, 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 test. Testing on the Zoom setting.
All right, I'm going to go ahead and get started. So I want to take a moment and say thanks to each of you for joining in. If you've not had me for a class before, I'm Dr. Zenon, and I'm going to be your Physical Science 1 lab instructor for the remainder of this semester. And I know that right now we're all experiencing challenges in terms of recuperating from Hurricane Ida and now this latest storm that's bombarding us with rain, as at least where I'm at as I speak to you. But you know, I'm glad that you could find a way to be here. And I want to assure you that, you know, if you keep at it, we're going to get through this semester. As my grandfather would say, by hook or crook, we're going to make it. So what I want to do now is to go ahead and share my screen. And I'll go back to the course homepage just to start from there. Now, let me say this. I know that there are some of you who have already started this class. You came out to the homepage as soon as you were able to. You read the information under the Start Here caption and you got started. The fact that you're here today means you found something, because otherwise you would not have had access to the link to join in. But
excuse me, the link was actually on the normal physical science page, not the lab page.
It's the same link. So
okay, I was just saying,
Yeah,
It's after
yeah.
I
So
saw
it's
it on
the
the lab page.
it's the same link.
Oh, okay.
So yeah. If you joined in, you know, this link is for office hours here. But the link to join in is basically the same information. Okay.
Okay.
So I think that's probably how you found me. All right. Let's make sure about that, because I want to say that the link is available in the syllabus right here and on the course schedule. If you clicked on the weekly overviews, it's the same link. So
Okay, I
I
see.
tell you what, so that I make sure that that's the way things are functioning, because I don't want to leave anybody out. Let me go. Let me just log out. I'm going to stop the share. I'm going to leave you just for a few minutes. I'm going to click on the link that's available in the lab class. And if it, you know, and it should bring me right back to you. Okay. So, and if not, then I'm going to come back anyway and tell you, here's the, I'll post in the chat the link that you can use. I want to make sure that, you know, there's no confusion and maybe there's not a whole group of people waiting for me somewhere else. All right. So bear with me for just one moment. Okay.
Sure.
I'm just gonna. Yeah, it's the same link. So I think we're good. So let me go ahead then again and share my screen. I was hoping we had more folks, but maybe they've got some things going on that is preventing them from being here. Let's see. Right. Share screen. There we go. All right. So back to the home page. Yeah. So yeah. So you can get to this link. You know, if you go into the weekly overviews, the link is there. I don't recall if I put it in the welcome message. Yes, I did in the welcome message. And if you clicked on the syllabus link, it's there as well. But on the home page is the link to my virtual office hours, you know, and my contact information, so that, you know, at any point, if you need to reach out to me for help, you have the information that you need to get there. So for example, you know, you can see that, you know, if I give a breakdown of my office hours in terms of each day and time, notice Wednesday has 2 time slots available, but I separated them because that one from 2 to 4 on Wednesday, which I'm probably going to go ahead and start that like next week, is like a virtual group tutoring. So there'll be students from any of my classes possibly in that room. And I'll just, you know, try to work in a way to resolve, to support the group. But if you want an individual kind of a session with me, then, you know, don't come to that session. Come to any of the others. And I even have some in-person office hours at the Plaquemine campus. I'm sure most of you saw the information saying that our Reserve and St. Charles campuses were damaged and are not online and are not being used this semester. So my office is actually in Plaquemine. And in fact, that's where I'm talking to you from now, because believe it or not, I lost power at my house about 3-4 hours ago, and they didn't tell us when it's going to come back on, and I didn't want to miss y'all again today. So I drove to Plaquemine, where I had access to electricity, to host this meeting. And so on Tuesdays from 11:30 to 1:30, if you wanted to.
Class, so.
Sorry?
I'm in the class, so.
Somebody's mic is open. If you don't mind, mute yourself. Thank you. So let me share that again. All right. So as I was saying, on Tuesdays, if you wanted to see me in person, we could do that at the Plaquemine campus from 11:30 to 1:30. It's a first come first serve kind of practice. As are all of my virtual office hours, and that I'm showing there on the home page, right? So first come first serve, and as I said, if I can't support you during one of these times, let's try to make an appointment, an individual appointment, where we can get your questions answered. You can always email me. If you email me, give me 24 hours to respond. If you don't hear from me in 24 hours, then I didn't get your email. Okay. So below the start here caption, below my contact information, there's information that reminds you that if you're going to function in this class, then you have to be logged in using your RPCC Canvas login. The way you know that it's a RPCC login is, notice right in the front here, it says rpcc.instructure.com. If it says lctcsinstructor.com or nunezinstructor.com, that means you're using another school's Canvas login. And the items on this left menu will not work. Many of them will not work if you don't log in from the RPCC Canvas login. Okay, so be sure about that, because I always get a few emails from students at the start of the semester, and which we're restarting the semester here this week. I always get a few emails from students saying, hey, I'm clicking on the weekly overviews and nothing's happening. It's telling me I can't get in. And sure enough, it turns out they're using, they're signed up at another school and they're logging into Canvas from that school's Canvas page. If you do that, the important left menu items are not going to work for this course. So, keep that in the back of your mind. That's why I put it right on the home page for you. And then below that, I give an explanation of all the items on the left menu that you have access to. And basically what I'm doing there is explaining to you what you will find at those links and how you navigate this course. All right. And then below that, I remind you that you need to pay attention to the syllabus, the course documents, the weekly overviews, and then you would have completed week 1, except that we got interrupted by Hurricane Ida. And so, I sent out an announcement saying I kind of readjusted things, and we'll take a look at the schedule, the weekly overviews here shortly. Okay. Below that, you have a link to science news and my bio. If those things interest you, don't hesitate to take a look. And then a reminder that if you don't hear from me in 24 hours, I didn't get your email. Okay. So is there any question from anybody regarding the basic content of the home page? Feel free to unmute your mic and ask. All right. So what I'm going to do now is a quick, as I like to say, quick and dirty overview of the items on the left menu. And then we'll take a look at the items that are on the right side menu. And then we'll jump into our first bit of physical science. Okay. So on the left menu, of course, the home button, it brings you back to this home page. The announcements. Please make sure that you check the announcements regularly. So, I had a welcome message there. I have a message or an announcement regarding the course project, which we're going to take a look at that next week. We're going to talk about the course project next week. Our first meeting was supposed to be on the 25th, but I was having major internet issues But, you know, I did let students know how they could proceed. I was having serious connectivity issues even before the storm. I had to actually get Cox to come out and had to go up on the pole and reconnect some things and all kinds of stuff for me that day. And that's why I couldn't join in. I sent out an announcement here a few days ago letting you know that because of the storm, I had to readjust. And so I changed the assignment dates and the schedule and so on and so forth. And I also wanted students to know if they had already started and even sent me items, there was no issue with that. You didn't have to redo them. And I do hope to get to the grading this weekend and you know, start to take a look at the items that have been submitted. And then the other thing that I want to say to you is that this meeting is being recorded and all of our sessions will be recorded. And after that session, I get the video, I have to submit it for captioning. And then once it's captioned, I will post a link to that video so that you have access to it. Okay. So the videos for each meeting will be posted. In the event you have to be you know, absent or you miss class, the video will be there to guide you in terms of the information that was shared during that meeting. Okay. All right, so announcements are pretty important. You know, you want to check them on a regular basis. All right. You can even go in the course settings in your Canvas settings and set up notifications so that you get notified on anytime I post an announcement. Okay. About this course explains that we're an online course with virtual lecture meetings. And that, you know, this and it explains how this course is organized. So you'll want to go and take a look at that if you hadn't done so already. This information is available on Canvas as well as in your syllabus. The syllabus, you have access to an accessible Word version, which you can download and print, or a PDF version. If you have not done so already, you need to sign and date the last page of the syllabus and send it to me as quickly as possible because I need to have that on file from you. And then you also see there's a link to our meetings. We meet every Wednesday, 5:30 to 7:20, unless otherwise specified. I can tell you that there are going to be a good number of times where we will finish early, but there will be times when we'll need the full you know, hour and 50 minutes. So just be aware of that. And below that, you have a listing of all the various assignments as well as their due dates. Now, you can click on these items. If you click on these assignment items, they'll open up. Here's the thing. You might not be able to, you won't have access to all of the information that you need to complete that assignment if you click from here, okay? So I often tell students, use this as a guide regarding the dates, kind of like a calendar or a reminder list or a to-do list. But don't try to access the assignments from this course summary page. We'll look at the weekly overviews in a moment, and that is where you should be accessing the assignment information on that on the left menu item under weekly overviews. Okay. Course documents, those are all of the logistical tools for this course. So a lot of this information is in the syllabus as well, but I like to just kind of make it available to you in multiple places. So feel free. For example, if you clicked on that, there's my schedule and information regarding the office hours. Again, that's available on the home page. But in addition, there's information on Zoom itself, right? So, you know, I try to be as thorough as possible because I know we're not seeing each other face to face. And sometimes, you know, you might need to have access to information immediately. And, you know, this might be of assistance to you, right? So there's a good deal of information here that can help you to function in this course so that you know how this course is managed, you understand the policies of this course. So I suggest, my suggestion to you is to go ahead and spend some time with this stuff so that you can function, so that you know how this course is being managed and the logistics and so on of the course. All right. Underneath course documents is useful links. These are academic tools. Course documents are administrative tools. Useful links are academic tools. These are some tools in addition to the ones you'll find in the weekly overviews. Okay, so these are just some additional resources that you might utilize as you move through this course, and you use these as you need to. Okay, so again, come and take a look and see what kind of tools I've made available to you. I'll come back to the weekly overviews in just a few moments. Below the weekly overviews is assignment and activities. This is not a listing of the assignments, but it explains each assignment category. So the various types of assignments that you will complete in this course are explained here. And how you submit instructions and information on HonorLock, which will be used to proctor a portion of your final exam. Okay, so if you want to know how to submit assignments to me, it's explained here. Okay, and you should follow that. If you want to know what's a lab report, how many of them are you going to do, how many points are they worth, what do you put in a lab report, take a look. Post-lab discussions are all explained here, how they're graded, what they require. Go and take a look, okay? You notice from here, there's a project. We're gonna talk about this project in detail next week, but, well, we're gonna talk about it and I will give details so that you can get started. Let me say that. But again, it's all there for you. And then even there's some information available on the regarding the final exam, but of course, if you try to access that right now, it's going to tell you it's locked. But some key items regarding the final exam, besides the exam itself, are provided for you. Okay, so that's under the assignments and activities menu option. All right. Evaluation of student performance. This tells you how you're graded in this course. Okay. I got to go in and replace this page. I'm glad I took a look at this because somehow I got the one for the lecture. So I will fix this one. This is on me. I'll make sure it gets fixed before I walk out of here today. But what you'll find in this page is a breakdown for each assignment category, how many points is worth, how many points you need to make a certain score. Okay, so I do apologize for that, but I'll fix that here shortly. It's a good thing I'm looking. But we can go in the syllabus if I didn't snafu that as well. Let's take a look because I want to make sure that I did right there. Okay, so this is the information that I'll replace on that particular page. My apologies for the mistake. But you can see here, it explains to you that you're going to do 10 lab reports. Ooh, yeah, I got to fix that there too. Goodness gracious, what did I do here? Okay. But post labs, how much they're worth, how many total points, a project and a final exam. You don't have a midterm in this class. So yeah, I got to go back in there and fix that. Probably I got to fix it in the other classes as well. So good thing we're looking at that, right? And then below that is a link to grades. If you click on that, you're going to see your individual grades. You do have access to a link the link that says people, which shows everybody that's enrolled in the course. link to the library, tutoring homework, the homepage, technology policies, which talks about all of the technology that's being utilized across the campus, this online learning readiness activity that you will complete as part of your introduction activities, if you haven't done so already, information on Honor Lock, a link to Trio, and the end of the course survey, which is not active right now, but again, there's a link on the menu that you can click on. These items are all hidden from your view. I have access to them because I'm a faculty member, okay? So shy of my snafu on evaluation of student performance page, which I will fix immediately after the courses, after we finish tonight. What questions do you have of me regarding anything that I've clicked on the left menu? All right, so now from the home page, on the right side, you see here, there's like a to-do list. And again, you can click on these items. My suggestion to you is do not click on these items from the right menu to complete them. Instead, utilize the weekly overviews, okay? Use this as a reminder list, all right? So you know what items you have on your plate that you need to complete. But when you want to access the item or the materials related to that item, go in through the weekly overviews. You do have access to the course calendar, which shows all of the assignments for the entire course. Again, you could use that as a reminder tool. So you have, you know, to-do list or reminder tools on the right menu and under the syllabus, but it is the weekly overviews that contain a breakdown for each week of the course, and it contains all of the assignment information that you need for each week. So I did go back, as I mentioned in the announcement that I posted, and basically reset this course to reflect the fact that for the first 3 weeks, basically, we've been dealing with either the hurricane itself or the after effects. And so we picked up this week. And so what I want to do now is I'm going to open this introductions overview and just briefly share with you this information so that you can complete it if you hadn't done so already. Again, if you've done so already, you don't have to do it again. But this also is so that those people who are not familiar with the structure of the weekly overviews can get a peek at how things are organized, and then you can go back and take a look at it on your own, okay? So each weekly overview, each topic that we cover has an overview, and that overview contains objectives, which tell you, you know, what it is, what is the you know, what is the reason for doing this stuff. Okay, so you can see this introductions overview is designed for you to get comfortable with the layout of the course. And traditionally, we complete this in week 1, but you know, things kind of got shifted a bit. So you'll be working on that this week instead, if you hadn't done so already. And the other important thing is for you to introduce yourself to your classmates. Okay. The other tab, and you need to make sure that you view all the tabs, just as it says down on the bottom here in the big print. The other thing that's important in each weekly overview is that it has the activities that you need to complete, and it has a link to each of those activities. So you see, you have several items that you need to complete or get to me by this Saturday. Okay. So a link to the syllabus is there. If you click that link, it's going to open up this syllabus menu item here. The signature page that you need to submit to me, information on how to submit that page to me, and all of the other items that you need to complete for this by this Saturday. And then it tells you here, you're going to email me your completed online learning readiness activity. And there's my email address. And then, of course, in each weekly overview, there's a link to the class questions form. So if you click that link, you could post any question that you might be having about this course, and I take a look at it and respond to you, but also your classmates are free to respond. This is not where you put any material that's going to be graded. It is where you ask questions about the course. If you have a question that is more personal in nature, either come and talk to me about it during office hours or email me, you know, individually, right? Don't post any personal types of questions in this forum. This is strictly designed to allow you to ask questions about the class itself, okay? And then each weekly overview contains a list of items that you need to review and read to help you complete the activities, okay? So all of these items relate to these activities that you need to complete, all right? And every weekly overview is laid out like that. So you have several items on your plate to get to me as part of this introductions overview, and you need to get those items to me by 11:59 p.m. on Saturday, okay? Any questions about this introductions overview? All right. And I will say this, at any point, if you're working, you know, between now and Saturday and you have a question, don't hesitate, email me. I'm more than open to addressing your questions. I know this is an adjustment process for a lot of us right now. You know, some students don't have internet. They're trying to figure this stuff out. Please be in communication with me so that we can, you know, work through the whole process and get you out of this course, you know, so you can complete this course and be done with it, right? Because that's the goal, that's the ultimate goal, right? You want to finish this thing, all right? So the topic area, besides the introductions that you're going to focus on this week, deals with error analysis. And the reason I'm having you focus on this is because this is a topic that is relevant for the entire course. So this is a skill that you will need to utilize throughout the course. And so that's why we're going to tackle it first, okay? And so you can see here the goals and the objectives for dealing with this material. And it matches very closely with the kinds of things that we have been talking about and dealing with in lecture class. Lecture class this week focused on measurement, and in particular, the metric system and unit conversions. And so in here, we're going to utilize that information to help us understand error analysis, okay? And so there'll be some things that you'll do to meet it throughout the activities to meet these objectives, all right? So here are the activities that we'll be looking at in just a moment that you have to complete by Saturday. And here are some resources to help you with this topic area, okay? I'm gonna cover some stuff, but these are some additional resources that you can utilize. Every weekly overview has resources regarding that topic under the required readings viewings, and that they're designed to support you completing the activities. Okay, any questions about how the weekly overviews are structured? Okay, so what I'm going to do now is I'm going to go into this experiment handout. So this handout gives you background information and explains the experiment that you have to do. Okay, that's what it's designed for. So let's take a look. Okay, so the goal here is to get you some practice with measurement and error analysis. Okay, measurement, because that's the topic area that we've been focusing on in lecture class, an error analysis because in a laboratory setting, you need to do an error analysis whenever you make measurements, okay? So let's understand what error is in a laboratory setting and what it is not, okay? So in everyday conversation, error and mistake are typically, thought to be synonymous, right? Error and mistake, they kind of mean the same thing when you're having an everyday conversation outside of a laboratory setting. But the moment you walk into a laboratory setting, they do not mean the same thing, okay? Error is part of the measurement process. Mistakes are not. Anytime you make measurements, you're going to have error because measuring requires you to use some measuring device or tool or instrument, and those instruments have a limitation, okay? Because no measuring device is infinitely precise. However, mistakes are not part of experimental errors. And it says here, mistakes are a result of sloppy work. I don't want to be harsh about it, but mistakes are things that can be eliminated. Error, you cannot get rid of. When you are making measurements, you cannot eliminate error. When you are making measurements, you can eliminate mistakes. Okay, and it gives some examples of mistakes that you want to avoid in a laboratory setting. I mean, you can have the best measuring device in the world. If you misread it, that's a mistake. You multiply 2 times 3 and get 8. That's a mistake. You copy the data down wrong. You use the wrong equation. Those are all mistakes. Okay, so bear with me just for a second here. I forgot to turn my ringer off. I do apologize for that. Yeah. All right. So what types of errors will you be encountering in a laboratory setting? Or what types of error do you need to be familiar with? Well, the first type is known as statistical error or random error. Random meaning it's not predictable, okay? It's not predictable. The error is random. There's no pattern to it. And so, as I said, anytime you're making measurements that involves reading some type of scale, that measuring device is going to have a limitation. And so whenever you're using that device, when you make a reading, you're going to be estimating the last digit of the measurement, okay? And it is that estimation that generates that random error, okay? And so we say that when you make a reading on a measuring instrument, there's uncertainty in that estimation, okay? Now, the reason it's random is because whenever you read a scale, you could estimate too much or estimate too little, okay? And so if you make a sufficiently large number of measurements, you can reduce that random error because the error should cancel on average when you have a large number of measurements, okay? So many measurements of the same thing or the same property or quantity provides a more reliable estimate because you can reduce the random error that way. Okay. You can eliminate the statistical error because in order to do that, you would have to do an infinite number of measurements. But the more measurements you make, the more you can reduce the statistical or random error. Okay. Now, that sounds great in theory. Oh, you want to reduce the random error? Just measure a whole bunch of times. The problem with that is you want to graduate. So you don't want to be measuring the same thing over and over and over and over and over. So that means, well, we got to figure out how to deal with that. Okay. So if you can only measure something once, and a lot of times that will be the scenario that we're facing, right? In a laboratory setting, you can only measure something once. So it tells you the error estimate on a single scale reading can be taken as half of the scale width. Okay. So for example, if you're using a meter stick has the smallest division of a millimeter. And so if you can only measure once, the best you can do is plus or minus 0.5 millimeters. Okay. So the way you read that measurement that they have listed there is 17.0 millimeters is the average, which if you only measure something once, that is your average, right? Plus or minus 0.5 millimeters, because if you only measure once, the best you can do is half a millimeter too much or half a millimeter too little. So another way you can interpret that measurement that's given is on the high side, your measurement can be up to 17.5 millimeters. And on the low side, it can be as small as 16.5 millimeters. So you have a range that the measurement falls within, right? So the more you measure, the smaller that error will be. If you measure once, it's 0.5 millimeters. But if you measure 10 times, it will go down. It will be smaller than that. Okay. And they even tell you here how you can calculate the error on the mean. Okay. Now, the good thing for you is that we're not going to be calculating the error on the mean. And I'll explain why here in just a moment. But you do need to know how to interpret a measurement like the one that's given 17.0 millimeters plus or minus 0.5 millimeters. You do know how to, you do need to understand what that is telling you. It's telling you that 17.0 millimeters is the mean or the average, and 0.5 millimeters is the error associated with the mean or the average. And the reason you need to know how to interpret that is because for the project, some of you might be seeing this kind of information in the sources that you're going to be using. Okay, we'll talk about project more next week, but just, you know, part of my job is to help you understand how to interpret scientific information. And so you need to know what these kinds of things mean when you run across it. All right. The other type of error that you will encounter in a laboratory setting is called systematic error. Systematic error. And so in this case, there is a system to it. There's a pattern to it. But the problem here is that you don't know the pattern. You have no way of isolating the pattern. And that means that the pattern is hidden from you. And so you can't detect it. And so you can't estimate or know the size of the systematic error. You can make a bunch of measurements, but though all of those measurements would be just systematically off. Okay. So the way you deal with systematic error is to calibrate your instrument. So, you know, you could get this systematic error because maybe you've never used that instrument before and you have no idea whether it's working correctly or not. Or maybe you don't know what kind of value you're supposed to be getting. And so to reduce systematic error, what you want to do is calibrate your instrument. And technically, you should calibrate it to a known standard. But, you know, we don't get into that in this class. That's a bit more sophisticated than we need to be for the kinds of things we'll be doing. And so if you're using any type of measuring instrument, what you want to do is just zero it. That's common language for calibrating it. Zero it out. Okay. All right. But one of the things they mention here at the end of this paragraph, which is very important, is that when you tell me reasons why, you know, when I asked you, explain to me why you think you got the error you did, please do not say human error. Human error means mistake. And if you tell me the reason my numbers are wrong is because of human error, I'm just going to write you, oh, you made a lot of mistakes, did you? Right? You need to be trying to come up with some, some deeper explanations for why you got the error that you did, right? Now they talk about accuracy and precision here. And we even saw this kind of information in the lecture the other night as well. But I will say this to you, my job here is not to overly frustrate you. And so we're not going to be focusing on this. All leads you to this accuracy and precision business, leads you to a discussion of significant figures. And while I value that is very important, we're not going to dig too much into that, okay? Because I don't want this to be an overwhelming process for you. This is an introductory class, and we can do without all of that. What I will say to you is when you are making measurements for me or reporting information for me, 2 decimal places is more than sufficient. As I say, 2 decimal places is good enough for government work. Okay. All right. So now, if we aren't going to be making multiple measurements to reduce our random error, and the best we can do is zero our instrument in an effort to calibrate, how are we going to tackle error? What type of error analysis are we going to be doing in this class? Well, because this is an introductory class, you are typically going to be working with properties or quantities that have a known or accepted value. In other words, we know what the right value should be. We know what the right value should be, okay? In other words, we can compare your measurement to the correct measurement and see how close you come. And the way we're going to do that is through a percent error calculation. So you're going to use percent error to compare your experimental values to the correct, accepted, or theoretical value, okay? And you see the formula for percent error written here on the screen, okay? Where you are taking your experiment value and comparing it to a standard using the formula that's given. Now, I'm going to write this formula for you in a moment in a much simpler format, so that it's more visually appealing and it's much easier to understand, okay? All right, so in order for me to do that, what I've got to do is stop the share, and I'll do that in a moment. But what I want to point out to you is that you do have an example given below where you can compare an experimental results to an accepted value using the percent error formula. And when you do that, the correct answer is 2%. And so you should try it on your own before you start the actual experiment for this week to see if you understand how to use the formula, okay? So let me just stop the share just for a moment. And what I'm gonna do is, if I didn't already, and I don't believe I did here, yeah, I'm gonna bring up a whiteboard. Whiteboard Fox, I like this website. And And so what I'm going to do here is I'm going to write out the percent error formula. Somebody, let me share again. I apologize. Let me not forget to share. Okay. Now I think you can see this whiteboard. Okay. Am I right in that? Somebody just kind of unmute and say, yeah, I see that.
Yes, ma'am.
Okay, thank you very much. All right, so I'm gonna write out for you the percent error formula. And I'm gonna write it in a way. First of all, I gotta get a handle on this mouse situation. So I'm gonna write it out and then we'll talk about it. Yeah, it doesn't let me. I apologize. I have to do this with the mouse. So if it looks like I'm a first grader, I am when it comes to using the mouse to write with. Okay. Minus. And I'm going to save this for you when I post the video. I might post this before the video because the video won't be available until about 24 hours because I have to get it captioned. Okay, so there we go, right. Value. Make that an A. Okay. Times 100. Okay. So now you can see from what I've written here, and hopefully it's, you know, it's legible. You can see this is written in what I call plain language, right? So you're going to take your experiment value. Anytime you want to compare what you've done to the right value, you can use this percent error kind of calculation. Let me fix this right here because this is ugly. And that's even uglier. Parentheses. Okay. So you take your experiment value and you subtract the right value. And notice that's in parentheses, so you do that first. And also notice these bars here. Somebody know what these bars are, what they represent? Anybody? Just unmute for me.
Absolute value.
Right. And what does that do?
Makes everything like a positive number.
Right. If you subtract and you get a negative number, the absolute value says, hey, take off that negative sign, right? So that means that our percent error is positive, right? So if you subtract on the numerator and you get a negative number, the absolute value says, nope, let's just look at the positive of that, right? And then you divide by the right value. Okay, once you subtract it, taking off the negative, if there is one, you divide by the right value and then you multiply times 100. Okay, so that means our percent error is positive, right? We have to be careful for that. All right. The other thing that's very important about percent error is that it is unitless. Because each of the items in this percent error formula have the same units. So your experiment value must have the same units as the right value in order for you to use this formula. And that means the units cancel out. Percent error is unitless. It is positive and it is unitless. Okay. All right. So I will be sharing this screen in your in the announcement that I post, but you are free, if you're taking notes, to write this down. All right. So now, if you're going to do percent error, it means you have to have an experiment value and a right value. So let's see what we're going to do for our purposes this week. So below the explanation of the various error types and the percent error formula is a portion of this handout that explains the process for you to get data for this particular error analysis experiment. This is basically a procedure, okay? So in order to complete the experiment, and bear with me, you know, okay, don't panic and say, oh, I need to go get these items. Where am I going to get them? I'm going to cover all of that in just a few. But this explains the procedure that you would follow to make measurements that you could use to do an error analysis or to do percent error calculations, okay? So if you had some cans of beverage, like a can of soda, a can of baby formula, you know, a can of broth, liquid items, that's why it says beverage. If you had some cans, they would be marked with volume units, such as milliliters, because we work in the metric system in this class. You would see fluid ounces, or gallons, or pints, or cups. Those are English units. But if you saw milliliters or liters, that would be the metric value. And so you would need some beverages marked in milliliters to complete this volume portion of the experiment, okay? And what you would do is take that can of beverage and measure the diameter. You want the radius, but you need to measure the diameter because that's an easier measurement to make. The diameter is the distance across the can through the middle, and then you take half of that to get the radius. And then you would also measure the height of the can. And notice it says you measure that in centimeters. Okay, so the height and the diameter in centimeters. That's what you actually measure. All right. And then you're going to take those measurements and put them into the formula to calculate the volume in centimeters cubed, cubic centimeters. Okay. All right. Cubic centimeters is a volume unit. It is a volume unit. Okay. And so whenever you measure the height and diameter in centimeters, and then you use the radius and the height in this formula, you will get a volume in cubic centimeters. All right. And then you would repeat that process for two different beverages. Okay, so maybe you had a Red Bull and you know, you had a big can of tomato juice and you had a can of soda, and you measured the height and diameter of each of those items in centimeters. You found the radius for each of those items by taking half of the diameter, and then you put those values into the formula and got the volume in centimeters cubed. Now, you want to compare the volume that you calculated using that formula given to the volume that's actually on the label. But when you look at the label, it's measured in milliliters. you calculated the volume in centimeters cubed, but they are equivalent. 1 centimeter cubed is equivalent to 1 milliliter, and 1,000 milliliters is equal to a liter. Okay, so there's a direct 1-for-1 conversion of centimeters cubed that you calculate using the formula and milliliters that you get from the label. All right. Do any of you have questions about this procedure? All right. The other thing that you want to do as part of this experiment is to look at mass measurements and use those values to calculate percent error. So to do mass, you cannot use cans of, you have to use cans of solid food. This is like a typo here. I have to go in there and fix that. That should say solid food, okay? So if you had like a can of beans or a can of corn, those are examples of mass items because they will have grams on the label. They will have English units, ounces, because you know in the United States, we use the English system as well as our primary measurement system, but we have to work in grams because that's metric. So you would actually put that can of solid food on a scale and get the mass in grams. And then you would look at the grams that's on the label and you would compare those two using a percent error calculation. Okay, so you have to do that kind of thing for 3 items. So let's say corn, beans, and I don't know what else comes in a can, tomatoes. All right. So that is the procedure. Now, I've made your life a bit easier. Why? Because if you look under activities, there's sample data. So you don't have to actually measure, but when you write your lab report, you do have to explain to me in your own words, what process would you have followed to get these measurements? Okay, so I'm giving you the measurements. I recognize that some people don't have anything in their pantry to utilize, or you don't have a scale that you could use, or you don't have access to a meter stick or a ruler. So what I did was I gave you sample data. Notice I gave you mass data where I gave you 3 items. I told you what's on the label and I told you what was measured on the scale. I gave you volume data where I gave you 3 items. I told you the height, I told you the diameter, and I told you the value in milliliters that's on the label. So you have the data that you need to complete this experiment, but your task will be to explain to me what's the procedure that you would follow to get this data. Well, I just went through the procedure with you, right? I just went through the procedure in the experiment handout where I explained to you what you would do to get your data. Do all of you follow that? I mean, you could make your own measurements if you hate my data. Maybe you don't like Dr. Pepper and you want to use something else. You can make your own measurements, but you can also use mine. But no matter if you make your own measurements or you use my sample data, you have to explain to me the process that you would follow to get the data. Okay? Do all of you understand that?
Yes, ma'am.
Okay. Now, yes, go right ahead, please. I thought I had another question. All right. Just below the sample data. Notice I'm under the activities tab. There's the experiment handout, sample data. Then there's a link that says what goes in the lab report. So let's take a look at it. I have given you the template to follow to complete this experiment. I mean, excuse me, to complete this lab report. All right. I also have provided for you submission instructions, but you'll see that that's also under the activities tab. Okay. So here's the report format. So after you completed the experiment, after you have your data, then you would come in and write the lab report. So I give you the title, then you need to put your name, and then you need to write me an abstract. Okay, and let me talk you through this abstract because I know this is the first time. Let me caution you, the abstract needs to be detailed enough so that somebody else can use what you put in your abstract to repeat the experiment. Okay, the goal of the abstract is to explain to someone in detail what they need to do to repeat your experiment. So explain what you did. That's the first thing. Explain the procedure that you followed. Okay, so you need to tell them in this what you did, exactly what measurements you needed to make. What did you do? You measured the height and diameter of 3 cans of beverage using a meter stick or a ruler, a metric ruler. You measured the mass in grams of 3 solid food items using a scale. Okay, so you've told them exactly the measurements that you made and the tools that you use. You also need to explain to them any formulas that they need to utilize. Once you make the height and diameter measurements, you need to do this and calculate the volume using this formula. You need to also calculate the percent error using this formula. So in that abstract, you're telling them what measurements they need to make, what calculations they need to do, and what formulas they need to use, what instruments they need to use to make their measurements. All that detail has to be provided. And then the third bullet says, explain why you did this. What was your purpose for doing this experiment? Okay. Well, I would think that if this experiment deals with measurement and error, your purpose should be focusing on the fact that you did this experiment so you could gain practice or experience with making measurements and calculating percent error or doing an error analysis using percent error, right? And then what you found. Now, this is a bullet that gives students a little bit trouble. So let me try to break this down for you. In an abstract, it is customary for a scientist to explain the error, the value of the data based on the error that was involved. Okay, so you're going to tell me, hey, based on the error calculation, the values of my percent, the sizes of my percent error, I think I did a great experiment. All my percent error values are about 10%. So I think I did a really good job here. Or, hey, I did a better job with the volume measurements and calculations than I did with the mass because my volume error is only about 5%, where my mass error is like 25%. Okay. You're not using a simulator here, so you don't have to worry about that part of it. Okay. But you do have to tell me how good you think your data and your analysis is based on the size of your percent error. I don't give extra points if your percent error is small, and I don't take away points if your percent error is large. But I will take away points if you don't do the calculations that I asked, and you don't tell me what you think of those calculations based on the size of the percent error. Okay, so if you don't tell me under what you found hey, I think I did a great job because my percent error is only 75%. I will take points from you. Okay? Because as a scientist, you have to make a value judgment about the usefulness or the, the significance of your experiment. And the one way you gauge the usefulness of it is by the size of your percent error. You make that decision, not me. I don't have a cutoff to tell you, oh, if it's below this, it's small. If it's above this, it's big. That's strictly your judgment. Okay? Any questions on the abstract part of the lab report? Okay, now let's get to the volume data. So it tells you right there, follow the layout below, make your own measurements or use the sample data. And there's another link to that same sample data. Okay, so you don't need to email me and say, hey, can I use your sample data? Yes, you can. You don't need to email me and say, hey, I don't want to use the sample data. Can I make my own measurements? Yes, you can. If you make your own measurements, that's what you use to complete the table. If you use my sample data, that's what you use to complete the table. This structure for the table is what you must follow. You cannot create your own layout. You must follow my layout. Okay, if you don't, I'm going to take points. All right, so you list the item name. This is volume data. List the item name, the height, the diameter, the radius, and I tell you how to get the radius, and then the volume calculation, and I give you the formula. Pi, which is 3.14 times the radius squared times the height, and you'll get a value in centimeters cubed. And notice it says what? Show all steps in this table. So don't do it on a separate sheet of paper. Don't write it below the table. You must show me in the table how you got your volume values. Show me the work. Okay, you can copy and paste this into a Word document. You can write it out on a piece of paper. You can type it and create a table that looks just like mine and fill it in, but it must follow this format. You don't have any leeway there. Okay. Any questions on the volume data? Mass data. There is the table that you utilize to lay out your mass data. And again, you can make your own measurements or you can use the sample data. So you see at every turn, you have access to the sample data here. You have it listed in the activities link. It is even under the required readings tab, just in case. All right. Once you have finished the mass data, then you're going to do your volume analysis. Please do not put the volume analysis in the volume data table. Do not put the volume analysis before the mass data. Follow the format that I've given you. Okay. So for the volume analysis, you're going to list the item name. You're going to list the value that's on the label in milliliters. You're going to list your volume in milliliters. Well, what's your volume in milliliters? Remember, this volume is in centimeters cubed, and your volume should be expressed in this table in milliliters. That's why this must be part of your explanation. 1 milliliter equals 1 centimeter cubed, because everybody in the world doesn't know that. So that's why it must be included so that everybody knows, how did you convert this centimeters cubed volume to milliliters? So for example, let's say you're using a can of baby formula, and you calculate the volume and you get 735 centimeters cubed. Here in this table, you should have an item baby formula, what's on the label, and your volume would be 735 milliliters. Okay, so here would be centimeters cubed. Here, you would just repeat that, but the unit would change to milliliters. And then you're going to do a percent error calculation. where you see I put the formula here for you, but remember you also have it written out in plain language right here. Okay. And then you're going to do the same process for the mass items. Okay. And notice it says what? Show all steps in this table, not below the table, not on a separate sheet of paper, not at the back of your lab report, not scribbled somewhere, nice and neat in the table. And then the last thing you're going to do for this lab report is to tell me what you learned, not what you did. Tell me something that you learned as a result of doing this experiment and writing this lab report. So explain a concept, a skill, a tool, or a formula that you learned as a result of doing this experiment. And also, please tell me in your own understanding, in your own words, why you never get 0% error when you make these calculations. Okay? Do all of you follow what goes in your very first lab report? If you've already done it and sent it to me, fine, if you're happy with that. If you now want to go back and refine some things that you did, feel free. You can always resend this to me, but you must get this to me by Saturday at 11:59 p.m. What are your questions about this lab report? All right. The other thing that you have to do is you have to complete this post-lab discussion. This post-lab discussion is based on your understanding of error analysis. Many of these questions can be answered by utilizing the background information in the experiment handout or relying on the process that you followed in the experiment and lab report. You have to answer these questions, and you have to also comment on 2 of your classmates' postings. And you cannot simply write, I like your answer, or I agree with your answers. Oh, hey, we got the same thing. Your job is to critique what your classmates have written by explaining why you might think what they've done is right or wrong. Or if they got an answer that's different from yours, have a discussion with them about, what they were thinking versus what you're thinking. The idea here is to recreate the environment where you have groups working on this together and sharing ideas and information so that each person can complete it. So you must answer the questions first, and then you go about engaging in a dialogue with your classmates so that when you're done, all of you are comfortable and have an understanding of measurement and error. Okay, this must be completed by Saturday at 11:59 p.m. So for those people who did not, haven't done anything, or even if you have done anything, you need to complete the items in the introductions overview and the error analysis overview by this Saturday at 11:59 p.m. What are your questions? Okay. I'm going to stop the share. If you are working at any point between now and Saturday at 11:59 p.m. and you have questions about anything in this week's material, please ask me. Don't hesitate. Okay. All right. So I appreciate your time this evening. I will post a copy of this recording in about 24 hours along with the whiteboard screen. I will go and fix my mistakes that I made in the one I have in the syllabus, and definitely here on Canvas, I'll adjust the evaluation page. I do apologize for that. And I'm also going to go back into the experiment, the the experiment handout and correct my snafu there as well. I do apologize. This has been a bit of a week in terms of getting prepared for you guys. So I apologize for those oversights, but I'll get them fixed for you. Okay. All right. So thanks everybody for joining in. I'm going to stop the recording